the instrument seen in the video is pH meter. So the initial setting requires setting of room temperature to 27 degrees Celsius, and the instrument is calibrated for testing of samples to measure pH by calibrating the instrument to 3 different values, 4, 7 and 9.2. For every testing of the sample, the beaker is cleaned thoroughly with distilled water and wiped with tissue paper. The beaker and the apparatus is cleaned with distilled water and wiped with tissue paper thoroughly before the calibration of the instrument is carried out. The sample buffer solution for calibration of the instrument to pH value 4 is taken in the beaker. And the electrode is dipped inside the beaker so that it is placed inside the buffer solution. And then if you can just see, the value is almost nearer to 4, but we can readjust and recalibrate it again. So it's almost nearer to the 4. So the calibration of the instrument to the value of 4 is complete. Every time the instrument is cleaned with distilled water and the electrode is wiped with tissue paper. Then the instrument is ready for next set of calibration. Now the buffer solution for calibration of pH value equal to 7 is taken in the beaker. And then the electrode is immersed into the buffer solution to calibrate the pH value equal to 7. The knob is adjusted so that the pH value is almost equal to 7. Now the calibration is complete. The next set of buffer solution for the calibration of pH value equal to 9.2 is taken in the beaker. And then the electrode is immersed into the buffer solution to make sure the value is almost equal to 9.2. You can adjust the knob to wait for a couple of seconds so that like the pH value is calibrated to value equal to 9.2. So this completes the calibration part. The tap water is taken in a beaker and the electrode is immersed, and the pH value of the tap water is noted from the pH meter. A couple of seconds is needed to be waited, and then the reading is to be noted. The reading is 7.24 approximately. Since the pH value is more than 7, the sample is considered to be alkaline.
As you can see here, today we are testing for total acidity. So we have taken 0.02 normality of NaOH solution. We have taken phenolphthalein indicator, and in the conical flask we have taken the sample of domestic sewage water. A 50 ml of sample is taken here, and in the burette again it is filled with 0.02 normal of NaOH. So now we are adding the indicator to the sample. A few drops of phenolphthalein indicator is being added to the sample. As you can see carefully, just on adding a drop of phenolphthalein indicator, the color has changed to permanent pink color. So this indicates that upon adding the phenolphthalein indicator, if the color is changing to pink color, it means total acidity is absent in the sample and there is no need of titrating it. As you can see here, today we are checking for mineral acidity. So we have taken 0.02 normality of NaOH solution. We have taken methyl orange indicator, and in the conical flask we have taken 50 ml of domestic sewage water as the sample, and in the burette we have filled 0.02 normal NaOH solution. So for the sample, now let us add methyl orange indicator. So a few drops of methyl orange indicator is being added to the sample. As you can see, upon adding the methyl orange indicator, the sample has turned to yellow color, which indicates that mineral acidity is absent. So no need of titrating it. So today we are checking for phenolphthalein alkalinity. So for phenolphthalein alkalinity, we have taken 0.02 normal H2SO4 and the indicator is phenolphthalein indicator, and in the conical flask we have taken 50 ml of sewage water, and again in the burette we have filled 0.02 normal of H2SO4. So now for the sample we are adding the phenolphthalein indicator. Phenolphthalein indicator is being added. It changes to pink color, which shows that the alkalinity is present. So we have to titrate it against 0.02 normal H2SO4. So initial reading of the burette is 0. As we are titrating it, it changes from pink color to permanent colorless, which shows that phenolphthalein alkalinity is present. And now you have to note down the final burette reading.
0.8.
Which almost comes up to 0.8. Note down the burette reading. The burette reading noted down is being used for the calculation of total alkalinity using the formula given in the lab manual. So today we are testing for the total alkalinity. We have taken 0.02 normal H2SO4 and the indicator here is methyl orange indicator, and in the conical flask we have taken 50 ml of sewage water, and in the burette we have filled it with 0.02 normal H2SO4. Now the indicator methyl orange is being added to the sample. As you can observe, 1 to 2 drops of methyl orange is being added to the sample, upon adding which turns to pale yellow color, so which means that total alkalinity is present. So now you have to titrate it against 0.02 normal H2SO4. It is being titrated until it changes to permanent pink color. So as you can see, a little traces of pink color is being seen, but you have to titrate it until it changes to permanent pink color. You are seeing the change of pale yellow to permanent pink color. It has completely changed from pale yellow to pink color. Now note down the burette readings. Initial burette reading was 0. So whatever burette reading you have noted down, use it for the calculation of total alkalinity using the formula given in lab manual.